So the iron and steel is in place. I have further done a little bit of gardening here, taking all of the sinks out to the north side. And that was actually easier to do than it would have been otherwise because I standardized on the north-south belts being at deck level. There's a few things here where I'm not precisely following it, but those would be easy enough to refit if this ever became a problem. For example, this overflow of, well, not overflow, the quartz crystals here should really go up above and then come down in their lane. So any other belts that I add further down the line here wouldn't run into it. Similarly with the silica. Although now that we're looking at the silica, we're on to the next bit of work here. There's still several more subsections to go. The next obvious one is that we need to be creating quite a lot more silica. And this silica source will be merged into that one as a priority merge. We'll get into how that logic works. I may dedicate a little chunk of space either on the top level or elevated above it or something for building the appropriate splitters and mergers to effectively do a priority merge. And in the end, because one machine or the other may stall for some reason or drain for some reason, we can't count on any specific ratios coming in. So if any silica comes through this path and it can't get merged onto the supply line to the next stage, it absolutely has to fall into a sink, so that there will be one mandatory sink here. So our next task is to do some silica. And that one, again, let me see if I can bring up my editor here real quick. Quartz outpost. There it is. Okay, so here are the plans for the silica outpost, or the quartz outpost. Now we've already got these refineries doing the pure quartz crystal. And in fact, that is taking up 366 of my raw quartz per minute. And I need 504 raw quartz coming in separately. So previously I had one drone port that was sourcing the raw quartz for the pure quartz crystal here, and that's been running just fine. No objection to that at all. It's turning out quartz crystal like crazy. In fact, let's look at that really quick. Let's make sure that's actually keeping up, because if it's not, now's the time for us to fix it. So here's our quartz line. And the easy way to see it's keeping up is, if it wasn't keeping up, we'd be seeing gaps in this line. And the other way to see that it's keeping up is for us to dive through the floor and see that indeed the pure quartz crystal refineries are running flat out at 100%. So we know that for the particular distance to the raw quartz, we have been able to keep up that 360 plus per minute raw quartz. I'm going to need 504, so I've placed 2 more drone ports already. And I wanted to get those in and let things stabilize. I ended up redirecting, let's take a look at that. It's DD2H. So previously, all of my quartz supplies were feeding right into the existing single wanter. So I had all these 6, each one of them has quartz, and we had one that wanted quartz. We now have 3. So now the 6 are divided 2, 2, 2. So we're kind of pushing things into everybody, and I believe that each one of these should be able to handle half of that 504, so 250 plus. The original plan calls for making 9 248.889% constructors. I'm going to build 10, and I'm going to run up 225. Maybe I'll run up at 250 to get a little margin. And that will turn out 2 over half full belts of silica. So, incoming. So that's going to be, I need a blueprint that has 5 silica constructors in it. I haven't even started on that, so you get to see me actually putting together this blueprint. I keep picking up my designers. Probably should just leave one somewhere convenient. Oh, and this hole here, this is one of our copper stations. I'd forgotten about it until I saw these drones moving up and down through my factory. So I need to work my factory around this. I didn't anticipate it being crossing here. And if we start getting longer, we will need to work around this guy who is iron ore. Okay. So if I have to, I will simply reserve this space, maybe make walls going up so the drones would like go up through a chimney. But the drones do go perfectly vertical to and from the drone port, and they'll get up to some altitude and they'll hover for a moment, then they'll take off. So a drone chimney leading up to, say, halfway up this guy, so about this altitude here, would be appropriate. We'll deal with that later. So the easy way for me to do one of these is to first start off with, what do I want to make this look like? Well, we need 5 constructors for silica. And I can either put them back to back and have the inputs in the middle and take the outputs from the outside and merge them together, or I can face them in so my input snakes around the outside and the output is the merge of the middle. I happen to like this layout a little better, so we'll do that. The second thing is, I'd really like to constrain it to the front 3, so I'm going to push things forward, leaving this back area open for whatever else I'm doing. For instance, the power line will be going kind of dead center in one place. So if I put this here, that leaves me with more than enough room to use a lifter to snake our input down from above. And there's a pair. And there's a pair. And I really only need one more. Now, if I went to 12, oh, I've had my editor up all this time. Oh, bloody. Before I show you the new numbers in the editor, here's what I was building. Basically, I compared nose to nose with the inputs on the outside and the output in the middle, which is where I'm going, with tail to tail, where the input would snake in the middle, and then the outputs be collected from the outside. I happen to prefer having my outputs come together in the middle. There's really no reason to prefer one or the other. So, minimum would be 9. I can go 10. What if I go 12? So I'm going to divide, first multiply 9 by 248.889, and I'm going to say if I divide that across 12, I'd be running 12 of them at 186. Well, I happen to like that. That puts me under 200, and while I am not actually worried about power shards, because I can just, get as many of those as I want, it makes my soul happy to know that I'm under 200%. So that leaves me with this spot here, which is where I have put my power poles in all of my other ones. So that's good. Let's upgrade this guy to a tier 3 pole. And I'm going to go ahead and connect it all up. Just like that. So now when we connect this vertically to our top deck, it will power everything. Now the next bit is I need to have lifters coming up from these constructors. I have a visitor. There's a drone. I need to get the upper deck, the mid deck area here, where I am placing my, placing my through holes. I probably should lay down, yeah, let's use glass for this, just so I can see things. I haven't yet gotten in the habit of bringing the glass up, but I don't have it on my, oh, I do have it, okay. I meant to put it there, and apparently I did, and then I forgot that I did. So let's put the glass in place. This allows us a firm foundation to place the through holes on while not obscuring the view. So for instance, I can look straight down here and I can say, that's where those go. And this one feels off. Oh, all of them are off just a little bit. Okay, so I didn't get them centered up. So let's place them dead center on this line, starting here, just like that. It's not important for the layout that these are exactly centered up, but it makes it easier to put things in the right place if the right place is always on the line rather than offset by 1 meter. Okay, and he's coming toward me here and away from me here. It'd be really nice if, instead of deleting it and replacing it, if I could hit H to turn it into the hologram and then nudge it. But that's not a feature yet. I think I've seen it being asked for. I went to ask for it, and I think I remember seeing it's already on the list. The list of things people are requesting. Not necessarily the list that Coffee Stain is working on, but yeah, they set their priorities. Okay, so there's where all the output comes. I'm going to place the mergers in so that they head away from me. There. Now by placing them like that, that allows me to add the lifters like that. He's going down. So when I bring this down close, it will snap it into place. Well, it would, except he's actually coming up. There we go. And that's why I double check everything, because I tend to make mistakes like that. Now this habit of extending it upwards and looking at where it's going, that's just something I do. I haven't seen a lot of other people doing it, but I've found that it gives you a little more confidence in knowing where things are coming from and where they're going. Haven't decided what's going to happen with the outputs yet. Eventually, I'll bring them up from this corner here somewhere, so they're kind of like all the other ones. And now we need to do the inputs. So I'm going to put one down as a trial first. I think here and here. I want to look at how that looks, along with whether it's actually clipping in or not. That's actually clipping in. And it looks pretty good. And this side, there. And by clipping in, I mean clicking in. I use the yellow soft clipping quite a lot because that's where parts, where the models will overlap each other. But that's okay because they are built to look good when they're overlapping like that. So now we put the other holes in the foundation. And now I can pick up the foundations and finish up the... Oh, wait a minute. No, I can't because now I need to distribute my inputs across all 6 of those. And there's a couple of ways of doing this. One way is the manifolds that I've been doing. But I think in this case, I am going to do a normal splitter, and I'm going to make it a non-manifold. So we are just going to do a fair split. I'm going to just bring it in just like that. Also means that they're not going to be nice rectangular edges. Okay. So what does this look like? Well, from here, that's going down. This guy's going down. That guy's going down. So I got an even split 3 ways from here, an even split 3 ways from there, and now I need a 2-way split going down in there. And I think I am just going to put it right here, and I am going to ramp this in. I don't use these small curves and small ramps very much. And this needs to go to wherever my input is. So we are going to pull it out here. Now's the point where I should nail down where my inputs and outputs are. This is a bad example. Let's go back to one of my earlier ones. So this is a typical top plate from the refinery stuff, which is where I really set the standard. And it is kind of in this foundation here and centered here on the left half of the foundation and centered on the part of the foundation like that. Okay. So I'm going to mark it with a hole even though we're going to be going up, not down. So this needs to go in here, and I want to send it up. So let's go vertical, and I'm going to put 8 of them in. And we're going to grab the mark. And now we come down from here, like that. I can delete that hole. Now, I could just do that direct. And because this is all underground and all that, a lot of people would just say go for it. But let's keep it nice and square. So there's my output, which I can then, when I put this blueprint in, I can just grab that and bring it up to somebody waiting. And it'll be in the same place as the normal top plate that I drop on top. And the other one, or inputs, these are going to be a little harder to chase down because of all the belts on the top of them. Is there one that's not so obscured? That's not too obscured. Okay, so this is left-hand side of the upper of this one, this particular foundation, just this way, just inward of the midline. Oh, come on. Nine because I'm bottom and top, and it was here. And I want to bring it down so it's level with this. So that's from here. Oops. This is a bring it down. 1, 2. That doesn't look right. That is in fact too low. So what I'm going to do is see if I can get a little guidance here. There. There we go. So our input will drag that down vertically to here. I don't really need that support. So our input comes in, gets split 2 ways, gets split 3 ways. Each 6th gets sent down to one of these guys. These guys are running silica. And at 12x, we're running 186%. I could run it all the way up to 200. If I run it at 200, that means that this percentage here is going to drop down a bit once we get going. Or I could say 840 divided by 12. So I need to produce 70 from each one. So let's set target production. Oh, thank you, autosave. Target production will be 70 per minute. Okay. And remember, this is in addition to the silica that is being produced as a byproduct of the other stuff we're doing. Very simple. So the only other thing I want to do is zoop something upwards and put a top plate in place. So when we clip something on the top, it clips it to the right level. And that level happens to be oh, come on. We want to default here so we can put on one at a time until we can't. And I peel off 2, and I leave 1, and I ditch the rest. Okay, and I don't feel the need to use glass in the factory itself. And this doesn't well, it doesn't hurt to have this as a floor. So let's zoop some flooring in here. And if we're going to have flooring, let's be consistent, and let's put our framework out front, like that. And that gives us our silica that we are going to place twice. So this is silica. Save blueprint. Now let's put it in place in my blueprint book so I don't lose it. It's on the hotbar on 8. And now we need to drop it down twice in a way that we can take these two lines of quartz from here, and one line of quartz goes in each one, and then the outputs get merged. So I think I'm going to put them just along this row, and I'm going to place one here so that we merge the silica from there. So 8. And I am locking it to the grid. Just like that. It turns out that I didn't actually need to put the plate on top. Well, let's do a normal top piece on these. So hit 9. This is the old original top piece, which has the sink on it, which we're going to get rid of. So I'm thinking that what I will do is in this area here, so in this grid square, I will have the logic that assures that I'm using up all the silica from the right and merging it with the silica from the left to go onward. And I will want 2 belts of silica coming out of that. So first off is our inputs. And these inputs are coming right down this line. Well, that's convenient. And I need to remember that at the edge here there is a 1 meter jog because I offset my drone ports. Means that the belts are straight, but the foundations don't quite line up. And that puts 1 drone line right on the seam between 2 blueprints. Okay, here's where the first quartz will drop off. And there's the second. I always seem to do most of my work at night. Maybe that's just because I notice it when it's night and I don't notice it when it's day. But at some point, I would like to grab all of the software engineers in the computer gaming industry that have flashlights that look like this crap. I would like to show them the kind of flashlight you really use when you're out walking at night. Your beam is wide angle so you can see the ground around you. So you have good notions of, what's outside of that little teeny cone. I want to be able to see what's right in front of my feet and what's out there. I want to see what's right of me and left of me on the trail. I don't want to be limited to this little teeny cone. So flashlight beams like this. I haven't had a flashlight like this since I threw away a flashlight when I was a Boy Scout because it had a beam like this. I mean, come on, people. We're smarter than this. We're better than this. Okay, so hook up our inputs. Now that I've had my rant for the day. And let's make sure this is pointed the right direction. 2, 3, 4. And that's the wrong height. Try this again. little trick with this. If you're facing just a little bit down and you move forward, you can click it up slowly. 1, 2, I got 2 clicks out of 1, so that should be 4. The other pro tip is every time you place it, you need to make sure that it's pointed the right direction. There. Now, this happened to be the right distance to make a nice right angle turn. The other one, I'm going to have to do a little bit more work. So what I'm going to do is I'm going to grab one of these. I'm going to say, here's our center line. That's where we're going, right there. Now, for consistency, let's keep it consistent. After all, I'm putting north-south at the level, so let's bring this in here, and then I will just use one of these guys like this. So that satisfies my rule about north-south being low and east-west being high. I'm violating a little bit here, but it's just that one thing, and I'm willing to accept that. So we've got our inputs hooked up. Let's get our power hooked up. There's one. And there's 2. Now we're actually stretching across 2 because we skipped an area here. Like I said, I'm going to use this for belt work. Get rid of this guy and this guy because we don't need them anymore. Okay, now hook up our inputs down below. Hook up our power down below. It looks like I didn't get power hooked up to these guys. Oh my goodness. Okay, only a couple of my, yeah, I didn't really finish the blueprint. Okay, so we'll do the rest of this by hand. I guess I picked up my constructors after I ran power and didn't check the power afterwards. Okay, so now run the output lifters. And the guys that drop the inputs. Okay, that's one of them. Everything is cooking off, so we are ready to go here. Let's run our output up, so we're done with this one. We just need to work out what's going on up top. And now this guy. Power. Okay, so we are connected up and down and around, and we're running. And now the outputs and the inputs. See, once you get the holes placed properly, which is really the most important thing out of the blueprint, putting the lifters in place is really easy. Notice how these first two machines started running early, so they've already filled up, and now we're just distributing to the other ones. Okay, so what do we have here? We have two over half full belts of silica here, and we have two small belts of silica here that we absolutely want to make sure get drained into a sink if they're not being used, but we do want to use them. We're actually budgeted on this build to use this silica. Although with the way I do margins, I will bet that I could sink this and we would still work. Now, these sinks over at the north end that I am using right now are strictly, this is stuff that I am not using yet, so when I put the sink in for the silica, I'm going to want to make sure that it's not picked up later by accident when I say, oh, now we remove all the sinks. And we want to get rid of this transport line completely. And I think what I'm going to do is merge these two together on one line. Now, if I merge it and split it, yeah, total amount of silica is 2 belts, just under. Well, 840 plus what? Let's see, produce. Oh my God, have I had the editor on the recording all this time? Oh, I am so sorry. So I just did all that stuff behind the editor, but it was placing down that blueprint. You probably heard what I was saying. Placed down the blueprint. I striped these guys in place, and I clicked them into the top, swung my mouse down, and they just went right into place. And everything was like that. Once you get to putting in the blueprints, it just, put in the lifter into the hole and then drag it down to where you want it. And if you're near where you're going, it will click right in as long as it's aligned. If you're off to the side by 1 meter, it won't click in, and that's your clue that you need to review where you are. So where was I? I was trying to look at how much total silica I needed. So we're producing 840 silica here at the constructors. And we are producing 60 more. So very small amount of silica coming out of our aluminum outpost here. We needed a little bit of aluminum scrap, and we do get silica as a byproduct. There is a recipe that doesn't produce the silica byproduct. I could have used it. I didn't elect to do so, and I'm not going to go back and rework this. So for now, we just need to take this 60 and merge into that 840. That's going to be a total of 900. So 450 per belt. So we cannot reduce this to 1 belt ever. We have to be running 2 belts. So I'm going to run this belt, and I'm going to do a series of splitters and mergers that will cause us to wind up with 1 belt that is mostly full and the other one that should be empty. And I can't do it absolutely because we don't have a prioritized merge. But we can do a chain of things that will make it work. So how do we do that? We have 2 of these lines coming over here. I am going to bring them down to to an appropriate spot, which I'm going to, for now, say is going to be here for this guy. And this guy I'm going to bring all the way down to same place roughly on this. Whoops. Like that. Oops. Okay. Problem. This guy's actually in here, so he needs to come to the left and then go up. So he's actually on this line. Just like that. Easy peasy. So these two, I believe those make connection. Yep, you see that we have silica in there. Can I make it all the way there? Yes, I can. And now this guy here, there. Now these guys need to go over that way. I'm going to stop them every... Oh, okay, so here's our seam. So we're going to not put a support in here yet, but 1, 2, 3, 4 here. Anytime I see a hole in the floor, I'll go ahead and just repair it. So I was thinking about doing it on this grid point. What I think I can do is actually do the priority merge on top of this guy. And I'm going to see if I can make it fit inside one of these lanes. You'll see what I'm doing in just a moment. So on the bottom, we're going to take a smart splitter, and I'm going to put several smart splitters in a row. And these are all going to be, oh, thank you, autosave. These are all going to be configured to split the output to the left and right and put overflow forward. Okay. Now above this, we're going to put a merger. Of course, that needs to go a little bit higher. Now recall that width, I could make that a lot closer in, but I don't need to. And this is kind of a little magical thing, so let's let it stick out and have ears. Go from here over to here, and up by 1, 2, and turn it. There. One more. So what's going to be the effect here? So on this first stage, we've got 30 coming in here, and we're going to send 15 each way, and they will try to merge 15 and whatever's coming in here in equal amounts. And that's not going to be too much of a problem. And if it takes in rotation, what it'll do is it will drain this line first, left and right. So it'd take 15, 15, and 15, and then it would fill the rest from here. Now remember, this has to be proof against anybody stalling. For this particular situation, 1 should be enough, but I am going to go ahead and make it a 3-stage thing. Because what happens in the second stage? Second stage says if we had any silica coming through here that couldn't be sent upwards for any reason, we're going to do the same thing again. We're going to send half of it one way and half of it the other way. And we're going to merge 1/3 from there, 1/3 from there, 1/3 from there, and then if anybody else has more, it'll get in. And then we're going to do it a 3rd time. Make sure that did not get correctly any, overflow any. Any, overflow any. There. We'll try one more time. Now we make sure that we have conveyors all the way through. So we're trying very hard to merge all of the silica from here onto this belt. If you do it the other way around, the problem is that it's going to try to merge evenly from however many. So it's the belt that you're merging from, in this case, that has the priority. Now, if we have any left at the bottom, we absolutely need to drain it. Now, the only way you can get to the bottom is if you come in from the right, and you can't be merged onto the top, for instance, if the top is backed up. So now we want to grab a awesome sink, and I'll just line it right up with this. Now this is why this needs to be off to the left. We do need to have a way of getting our silica from the other line through. Oh. Okay, let's do a blueprint of this. Clear Designer. So I want to do this compact. I want to leave space on the right to bring more stuff through. So I want to start it in this lane. So we want to be here. I'm going to be merging north. I think that's about where I started. Okay, so here's the beginning of the grid. We have our frontage area. We have this lane where we're bringing our silica in, and I was right on this seam. So this is a splitter. It's a smart splitter. I'm using a smart splitter so that I can use overflow going forward rather than 1/3 going forward. Put 3 of those down. Programming. Any to the left, any to the right, overflow forward. And I'm going to bring out a little tag here saying this needs to go somewhere. Same thing here. Little tag saying this needs to go somewhere. Now at the top we have the mergers. Conveyor merger, output to the left. And now I am going to put in some some through holes, because I now see that I do need to be fairly compact. Not totally compact, but let's at least bring it in a little bit so the ears aren't quite so big. Now, if I was starting off with two belts with a lot of traffic on them, wait a minute, that doesn't seem right. Yeah, I had them backwards. If I were bringing two belts in for this priority merge that both had a large amount of material on them, I might go for many, many more stages, but each stage would be reducing the low priority stage presence on the belt by 1/3 in steady state with nothing stalled. We're going to do that and that. So here's our low priority input, and how do I want the output to look? We're going to rise up there. Yeah, we're going to put it here, and I will reroute those inputs and outputs as appropriate. So let's get rid of the glass and the poles. Oh, come on. I really don't need the conveyor poles on this end. So there is our priority merger. Now, where I place this on the grid doesn't really matter because I didn't do anything to set my size out, so we're just going to call this 3 shots at merging from the low belt, high priority, onto the high belt, low priority, with remainder sent out left. Now I'm going to use a splitter icon. And let's see if I can build this properly. The other thing about doing this as a blueprint is if I place it in the wrong place, if I've placed individual things, I have to carve it up manually, one part at a time like this. Okay, so blueprints, priority merger. What the heck? Did I remember to hit save? Haha. Yeah, okay, so this was clipping against the entire blueprint that was here before. Not a good idea. So, I bring it in here. If this guy is centered, yeah, okay. So I'll center this where I want the belt to go out, which is going to be here. And the lower one is going to be silica in from the left and recycled out to the top. Let's see, where did my silica come in? It's here. So it's coming in on that center line. And I want to put this here. And this guy, same location, but I'm putting it over here. So I think this is putting the, yeah, okay, so this happens to have aligned it on the left half of the foundation and the right, yeah, and the left half up here. That's good. So if we do that, and that goes to the sink, and that goes to our output. Same thing here. Bring this out to the line, back to elevate, and I elevate it to I. And this gets striped back out to the grid lines, 1, 2, 3, 4, 2, 3, 4. There. And now sinks. I think I'm going to just put the sink in here for now, about there. I'm eyeballing it. I think that's about where it comes out to being able to connect up nicely. Yeah, how about that? I guess the more you do this, the more trained your eye gets. And now we just roll this up here, and I'm going to align it. I don't know if that's in the exact same place. It's not in the same place. It's not supposed to be in the same place because our alignment's different. Yeah, let's leave it. So now these guys come to here. I think I can bring this one straight forward. See if this clips through anything important. Okay, so what it clipped through was this, because I am violating my rule of having more than one thing at that height. However, because these two inputs are vertical, they can't be perfect. So what I can do is I am going to put in a lifter here to bring it down, and then I'm going to bring in a ramp, which doesn't help. Oh, blast. So, for now, I think that this line needs to go back down to ground level. Just temporarily. Just until about here. Okay, it's a design rule violation, but it's all part of this kind of unified thing. And I didn't think it was going to bug me this much, but yes, that S-curve does bug me. So here's where we're lined up. And here's where we need to be. Nope, one further this way. Here. So that leaves you with 2 lines of silica coming out here, each one of which has been as much silica as possible has been brought in from here. And let's give it power. Now you notice that we are completely stopped up here. So our silica coming from the machines that have to keep running ends up right there. And I'm going to take a pause here for a moment. I've got a cat that's meowing at me. And I've been doing this with my editor up. So this is entirely too fiddly for me to completely redo. But the core of it is that each one of these things, there's a priority splitter on the bottom, which is saying prioritize sending it out the right and the left, which is these ears. And any overflow goes straight through. So we're giving many, many chances for our silica on the lower line to merge into the top line. And the top line becomes the output, and the lower line, anything that doesn't get merged into it, gets put into the sink. So as we are consuming from the output, this will take one from each side and one from the input. And then as long as there's nothing available on the sides, because that's only 30 per minute, it will take from the input. So we'll do that 3 times. So 1/3 times 1/3 times 1/3, if everybody has silica all the time, is how much silica we take from the top. That's 1/27th. So if the bottom and top inputs were saturated, 1/27th of the output would come from the low priority, which is the upper belt. Make sense? Good. And the cat agrees. She is looking at this with such fascination while I'm rubbing her head. And with that, I'm going to call it a recording. I'm going to kick myself a few times for all the times that I left my editor up on OBS rather than taking the editor window down so you could see what I was doing. I will take this massive amount of silica I'm producing, and it will go into a pair of sinks over on the north side with everything else. So we can then continue our labors with whatever the next one is. I will see you when I have that planned out.